All right, so hello, I'm Llewellyn Falco. So I want to do sort of a show-offy talk today. I want to demonstrate 5 or 6 techniques that you probably haven't seen that individually I've found value from, and together I have found a lot of value from. We are going to do the Gilded Rose Kata. How many people have done this? Just show of hands. So just like 3 or 4 of you. Okay, cool. Now you do not have to have done the kata for this talk to be valuable for you, but it will help. So, well, first let's talk about this. Gilded Rose Kata is out here on GitHub from the fabulous Emily Bosch, who is here at the conference speaking, I think later tomorrow or earlier tomorrow. And kata is just a fancy word for practice, but it gives you some legacy code, which is useful to have when you're practicing, right? And whoosh, we need to implement this feature. Conjured items degrade more in quality twice as fast as normal items. That is our goal for today, and that is why we are in the code. All right, so let's look at the code. By the way, can everybody see that? Is that big enough to read in the back of the font? Cool. All right, so she has actually written a test here. We'll get to that in a second. Oh, not that. Probably this. There we go. So here is the code. Hopefully that makes sense to you. It does not make sense to me, but I want to talk about a couple things I'm going to do while I'm doing this. First of all, I'm going to take this quote from Abraham Lincoln. Give me 6 hours to chop down a tree, and I will spend the first 4 sharpening my axe. I actually like the way Kent Bett said this better, which is make the change easy and then make the easy change. Warning, the first part might be hard. So I'm going to spend most of my time making this easy to work, and then we're going to implement the feature. And I really want to point this out. The difference between a good programmer and a great programmer is that the great programmers are extremely lazy. I want you to pay attention to how much I am not thinking during this session. Right? How little I understand of the code base. That is the goal of what I'm doing here. Oh, and I am going to use Arlo's Git notation. This is just a little, it's like Hungarian notation. It prefixes my Git commits, and it assigns risk. So up here, the capital letters, those are things that might break production. The exclamation marks, those might break production. But the lowercase letters, those are safe. And I'm going to try to get from point A to point B with as much safety as possible. I find it just a good practice, but depending on the context, sometimes releasing is very hard at some of the companies I'm at. And being able to release without having to do regression testing is useful. Actually, usually what's more useful is being able to release without having to have a meeting about whether or not we should do regression testing. Right? So I will do remarkable things to avoid that meeting. So step 1, we need to get this under tests. Get a little bit of safety in our lives. Where am I going? Not here. There we go. Okay, so we have a test. We can run the test. It fails. Woo! That's step 1. However, look at this. It says fix me, but actually foo. Is foo correct? Yes, foo is correct. Why is foo correct? Because that's what the code does. It's the only gift legacy code will give you. Take it. Successful test! Let's do a check-in. So, T, because it only hits the test, test works. All right, next. This doesn't really tell me too much, right? So instead of the name, I'm going to just print out everything that's on there. Hey, test breaks. But look at me copying and pasting like a real professional programmer. Oh, whoa. Not sure what happened there. I am clicking like a madman. There. Hey. T, better tests. All right. I can actually do a one step better than this with a utility called approval tests, which I'm going to add now. So this is Maven, so I'm just going to copy this Maven text, add it into my POM file. And there we go. Install. Let's clean up that code. And now, instead of saying assert equals, I can instead say approvals.verify. And now I have to do the copy and paste in an editor that will pop up. So that's my copy and paste. And still only touching tests, so added approvals. All right, next. Am I done? I've written a test. Let's find out. This is code coverage. Ooh, look at all the pretty green. Ooh, look at not all the pretty green. Okay, so I'm not done. I'm going to have to write another test. So let's start making a step from one to many. And the best step between one and many is many of one. So I'm going to take this here. And I'm actually doing a little bit of refactoring right now. So I'm going to start using something from Kent Beck called test commit revert. So I'm going to send a test commit revert test. And just if I run this now, it passes, it opens up this little window, and I can put right here, added TCR. And just commit that way. But you might have noticed that was a little bit long. Like there's that little delay because swing sucks. So I'm going to cheat a little bit. And instead of using test commit, I'm going to use faster test commit revert, which only works on Llewellyn's machine, but calls out to an Apple script and pulls up the message box much quicker. All right, so now I can extract this into a variable. We'll call it result. And that's actually a provable refactoring because I used the tooling, right? So next, I can take all of this and extract this into a method called doStuff. And that is also provable because I use the things. And now I can change this. I forgot what I want to do. So let's run this under color again. And it looks like the first line that's not green is name is aged brief. So I have to do something with the name. So let's take this foo and extract it as a parameter. Introduce parameter, and we'll call it name. All right, so again, provable refactoring. All right, and now I'm going to pause my test commit revert and move forward. And instead of doing an approvals.verify, I'm going to do a combination approvals. Verify all combinations. For this, let's get rid of these. doStuff with names. What are my names? Well, this is a name. That's one. This is many of one. Now I have names. And kill those two things. This is going to break my test for a second, but in a very specific way. Well, first it's going to break it because I have to throw an exception. Next, it's going to break it by adding the input. When I gave foo, I got the same result I got before. So just adding a little bit of detail. It's still right, so I can move it over. And I'm going to toggle. This is a little hard to toggle, so I'm going to do the same thing with using a run with faster test commit revert runner. All right, and now when I run it, mini tests of 1. All right, so let's run that under coverage again. Look at the result. Age Bree seems to be important. So let's bring that back and run it again. This is what age Bree gives me. Is it correct? Yes, because that's what it does. Two tests. Am I done? No. Apparently this also means something. Comment that out. Is it right? Yes, because that's what it does. Three tests. Okay, this is no longer a name. This is a quality. So which one of these is quality? The last one. So what I would like to do right here is introduce parameter. But everything's going to mess up because the tooling isn't good enough. So what I'm going to do is I'm going to delete this 0 and say quality, introduce it by hand. Instead of an int, because we're in Java, I'm going to have to use an integer called quality. And I'm going to need some qualities as well. So integer qualities equals 0. Ooh, nope, 0. And now I'm going to pass in qualities. Not a valid refactoring, so I'd have to use the 3 exclamation marks, except it's all in the test, so I'm okay with it as well. Comment out that, and let's run this. Now, again, the only change is it's telling me my inputs. Parameter. All right, next. Quality is around 0. Now, I could think and figure that out, but that would violate my original rule of lazy. So how about 0, -1, 1? Those are things around 1, or around 0. Oh, look, it undid it because test commit revert, and approvals always breaks the first time you run it. So let's comment that out and retype it. 1, -1. Okay, now notice I'm up to 9 tests. 3 possible inputs for the numbers, 3 possible inputs for the letters, 9 combinations. Is it right? Yes, because that's what it does. Oh, let's commit that. Test, 9 tests. All right, but is it good enough? No. We also have this thingy. Let's add that. So now we're up to 12 tests. We got quality. Quality is something we have, and it was around 50. So again, let's not be too smart about this. 49, 50, 51. We're up to 24 tests. Are we done? Almost. Looks like we need cell-in as well at 6 and 11. So first, we're going to do the same thing we did before. Integer cell-ins. cell ins, integer cell ins. Now, well, first, let's just put 0. Small steps. When I run this without the commit, I'm expecting it to fail in that particular way where only the added input is put in. Let's commit that. Added cell ins. And now, we need things around 0 and 6 and 11, and that's just too much work. So principle of lazy in place. Let's get everything from -1 to, say, 15. All right, so now we are up to 408 tests. And now we're done with testing. We've gotten our safety that we need. It's time to shift gears and do some actual work. Let's start refactoring this. I'm going to use something called a lift conditional refactoring. It is a refactoring you probably haven't seen yet, but it is predicated on this, that I have completely safe coverage. Not just 100%, but actually mutation safe, meaning any number that's different is going to give me something different. So, first of all, we got this big old block of code. Let's pull that out as do stuff. Okay, wait, hold on. That sucks. So why am I passing in I? Because, okay, never mind. Let's not do that. Let's take item of I and pull that out as item. That should work. So this is provable refactoring because I use the automated refactorings. Local. Next. Let's take the rest of this and pull that out. Nope. That would be the other side of proving. I think it's to here. Yep. Do stuff. All right. That should work. Next. This is really tricky. I'm going to do the whole thing again. Do stuff 2. Woo. And now, pay attention to this. I'm going to add an if statement. And I can put anything in here. I can put true. I can put false. All the options. In this case, I'm going to put in this thingy. Now, is this provable? Not because I typed it. That's bullshit. But the fact that I have complete coverage, which is my weakest form of proof, but that it still works, that is my proof right now. I'm in a place where I have complete coverage safety, right? It's not a normal place to be, but added empty if. And now I want to add a return statement at the end of this method. And I'm going to show you a different way of proof. So far we've looked at coverage, we've looked at automated refactorings, but there's also scripts. So here are some scripts the team out at Tableau came up with. And here we're going to do the add explicit return script. So step 1 is copy. There's a lot of copy and paste with the scripts. Return. I'm going to add this after the method. And if it's truth, then the code should stop compiling. So I believe the method ends here. I add the return. I get my proof, the red. Step number 2, I'm going to move the line up 1. So I'm going to take the line, move it up. My proof is the code starts compiling. I have effectively added an explicit return at a method. Added return. Now I'm going to do another refactoring. Again, don't have proof for this one, but I'm going to take this and move it in to both places of my if and my else. My proof here comes from my tests. And now I'm going to do an inline. And now something magical happens. So that's a valid refactoring because I did it with things, so inline. But now look, I lost my 100% code coverage. Because those are dead paths. So, hopefully you're not colorblind. We're going to delete the red. Delete red. Oh look, we got more red. I'm going to delete that too. Oh look, I got more red. I'm going to delete that too. Look, I got more red. I'm going to delete that too. Are you paying attention to the lack of thinking I'm doing? All right, I looked, oh no, more red down here. Now I've got yellow. Yellow means it is either true or false. So we look in here, if the name equals age Bree, if the name is not age Bree, it can't be both age Bree and not age Bree at the same time. So this is always false. Delete yellow. And in fact, false and means that this is always, always false. And by the way, just in case I'm stupid and I get this wrong, remember that I actually have proof. So if I run that, this actually is deleted by the time it comes up because it's already reverted the file back to false. I cannot get this wrong. I mean, I can get it wrong, it just undoes it for me. Okay, so this if statement goes into it, which means it must always be true. This statement does not go into it, so it must always be false. This statement always goes into it, so it must be true. Is it true? Let's find out. Nope, I messed that up. Let's try again. Oh, the first part of this is always true. There we go. All right. This goes into it, so this must be true. This goes into it, so this must be true. All right. It looks like I have taken care of my yellow. Now it's time to clean up those if statements. So if false, like that's, what's that going? So we're just going to remove that. Clean ifs. If true, that's stupid too. So let's remove that. Clean ifs. This is also stupid, so clean that. This true, no automated refactoring for that, but fortunately I have my tests, so it's still not dangerous. This, and clean that. This, we can clean that. All right, so now we've cleaned our ifs, it looks like. Now look, this stuff is age Bree, so let's extract this. And actually, what is this is called update quantity. So let's call this update quantity for Bree. And now I have my first understanding of what the code does. This does update quantity for Bree. What does that mean? I do not know. But this, wait, did I run that? Bree. This thing must be everything else. That doesn't work as a name. How about that? All right. Whoa, not what I wanted. Undo. this is everything else. What is this? Extract. Okay, now, look, I return after this if. So I can delete the else. And now, you might feel this is familiar. I can do an empty if-else statement. Right? And let's do the next thing on our list. This thing. Now I can move this in. Now I can inline it. Now I can delete my red. Now I can delete some more red. Now I can delete some more red. Is it here? Is it here? Well, fortunately it will tell me. Now I can delete some more red. And I think I gotten through the red. So now let's do the yellow. This goes to the other part, so it must be false. This must be true. This must be false. This must be true. This must be true. All right, now we can clean up our ifs. So back up to the top. Remove the conditional. True. Remove that. Remove that. Remove that. Remove that. All right, we got through all that, so that means this first thing, what is that? Backstage passes. So update backstage passes. And that means this, oh, well, let me run that. That means this other part is everything else. Oh, that was the wrong message. Sorry about that. Okay. So now I do this for age brie, I do this for backstage passes. I can repeat the pattern again. Run that. Add another if else. And this time it's this thingy. I can move it all in, same as we did before. And I can inline it. And we are back to coloring by red. All right, so delete the red. Just while I'm here, this if statement is now empty, so I can just delete that. This if statement is also empty now, so I can just delete that. let me give the coloring back. This is red, so I can delete that. This is now empty, so I can delete that. This is red, so I can delete that. Oop, let's do that again, because I didn't actually commit. This is now empty, so I can delete that. This is now empty, so I can delete that. This is now empty, so I can delete that. I feel I'm pretty good understanding of what sulfurous tandem-ragus does. It does nothing. So I've now achieved an actual understanding of part of this code base. Feel good about that. Let's see, do we have more red? We do not, but we still have yellow. So this yellow is going to be true. This yellow is going to be true. This yellow is going to be true. Oh, no. All right, and now let's clean up my ifs. So I can remove that. Clean ifs. I can remove this. I can remove this. All right, and now this is actually update the default stuff. So I'm getting to a fairly good place right now. It's almost time to start getting to work, because what I'm supposed to do is make a conjured item that's sort of like this. I forgot what the thing is actually. Conjured items degrade in quality twice as fast as normal items. Okay, so I need the quality to be able to degrade easily. Well, okay, so this quality is a 1, this quality is a 1. So this is sort of like degrade rate. Oh, local. It did it on the cell-in as well. I'm just going to inline this particular one. No. All right, I'm just going to do it by hand. Test, don't fail me now. All right, so now I have an easy way that this degrade rate works. Let's just prep this a little bit more and introduce this as a parameter. Degrade, degrade. Come on. There we go. All right. So now I need to do some new feature work. So let's go write a new test. So test. Oh, not that test. Yeah. That test. All right, so test conjured. And let's just do an approvals.verify of do stuff with the name conjured pot and a quality of 10 and a cell-in of 2. So I'm going to run this. It's not going to give me the right result because, oh, it's not going to give me any result. Let's do that again. And let's comment out test commit revert. So test conjured approvals.verify do stuff conjured pot quality is 10 cell-in is 1. Okay, so this is not really what I want, because instead of going down to 9, I needed to go twice as fast, so down to 8. That's actually what I want. So let's go and actually do that. So here, I don't even want an equals. I really feel like it should just be contains. Conjured. And if it does, then I want to update the default with 2 instead of 1. All right, that passes. Only one less thing to do. Feature. This is my first thing that can break production code. Conjured items. And that's the whole thing, with 48 seconds to spare, in just... Wait. Oh, I have my revision count wrong. Damn, so we might have to do it by hand. It's a lot of commits. So, we tested it. We did a lift if conditional. We split it. Oh, we didn't split it into classes. It feels like it wants classes, though, doesn't it? Yeah. And then we added the new functionality. One thing before I close and take questions. Tonight, there will be a group of us meeting in the green tent, which is right across the street, doing programming till we're tired and we go home. You're welcome to join late. You're welcome to join early. You can stay the whole time. Either way, we'd love to have you. If any of that stuff in the pre-game session sounded good, come try it out. Thank you. There are lots of resources. There is also, whoa, don't cut it yet.
Sorry.
Jump back for 1 second. There. So you can actually download the slides as well. I also believe Craft will put a link to them. And please connect with Twitter and LinkedIn. Now get rid of that.
Slido. The questions.
All right, so let's start with, do you squash these commits before pushing to remote? No, I do not. For a couple different reasons. One is, it is really useful if something goes wrong to have these. We were in a situation where we did some refactoring. We broke, not our unit tests, but our full test cycle. We did this on a Friday, so on Monday we came back and they're like, oh, they broke stuff. We looked through and we only had 2 exclamation marks in a list of like 20 commits. So we rolled to the first exclamation mark, ran the whole test suite, which takes about 10 minutes, rolled them forward, ran them again, saw that we broke it, and when we spent 2 hours trying to write unit tests that proved that we did it. We succeeded in writing unit tests that proved that we broke it, but they were not helpful at all in figuring out why. So the next day, we went back to the beginning and we just redid that one step. It was 4 lines of code. It took us 10 minutes to rewrite the first time. We did Provable Refactorings the next time, and it took us 25 minutes, so an extra 15 minutes. And we got to one stage where we saw this line of code, A times B divided by B. And that we didn't have a provable refactoring to say the B's cancel out, but also that's only true in math. That's not true in code, right? A times B divided by B does not equal A for all floating point numbers. And so now we knew how we broke our code. And now we also were in a position to say, we don't care about the computer, we care about the math. And so we were able to go and fix our tests so they acted appropriately. Now, what I do wish is I could roll up that Git had like tree stuff. I wish I had that. It doesn't, but I don't like the squash. Also, I recently put a hash or a tweet out that said, Axiom of Refactoring, between any 2 points, you can refactor in small steps. And people got mad and they sent me examples of how it was obviously impossible that I then did and showed them this list. But the interesting thing is, if I squash that, how would anyone ever accept it as a refactoring? If they think it is proof it is impossible to refactor, right? Like if I squashed this whole thing and said refactoring, you would say no, and you would reject my pull request. Like there's no way you could follow that if I squashed it. You make it look easy. Thank you. I suspect it's like trapeze artists make it look easy. Yes. So let's just talk about that in general. Practice. Trapeze artists practice quite a lot, way more than they perform. In fact, most places do. I recently went to a Broadway show, and they did salsa dancing in it, and it was awesome, and I was thinking, holy crap, I can't even salsa dance for 2 hours like that. And they probably practiced that day, right? Somehow we've gotten into an industry where we don't practice at all. And that's horrible, right? Especially since there is a difference between performing and practice. Like, how many people here use typing as part of their day-to-day job? Anyone? Okay, we got a few in the back. Good. So, have you been working for, like, say, 10, 20 years, maybe? So you must be really good at typing. 100, 120 words a minute? No, because you haven't practiced typing at all. You've been performing typing. And performing doesn't make you better. It's practice that makes you better. Right? The reason this is easy is because I practiced. Right? And I really encourage all of you to practice. Make time for practice. Get your work to make time for practice. Nothing is worse at a company when they're like, learning is something that shouldn't occur at work. Maybe we'll do it during a lunch. Like, oh my God, that's so horrible. Like, practice. Make space for practice. It is so important. It should be done at your company. If it's not, you still have to practice because it's your life. But I would suggest finding a company that will allow you to have it there, right? There's a lot of companies. This morning, the astronomer was like, there's only a few jobs for astronomy, but it's not true in programming. In programming, if you don't like your job, you can change it. Take advantage. That is a privilege so many people do not have.
We have no time for more questions, but go to the Coding Dojo and you can continue this. Thank you so much for this wonderful talk.
Thank you very much.
And this is a little gift from Craft for you, and actually this is a portrait of you.
Oh, that's so cool.
Thank you so much.